In this example, we are asked to use a least squares regression line and a TI-83 84 Plus calculator to model the data in the table. The first step in the process is to enter all of the data. First, you must recognize that the first year in a problem such as this one is usually designated as year 0. This means that the model we derive will include the variable x, where x is the number of years past the initial year. So in this case, x will be the number of years after 1990. To enter the data, first press the Stat button. We want to edit the data, so press Enter. You should see a screen similar to the one above. If there is already data in the screen, you should clear the data out. Please see your instruction manual for procedures on clearing lists. If your data screen is ready, you can start by entering the first data point. Remember, we will not use the number 1990. We will use 0. If you are not sure why we do this, please ask your instructor for more information. Next, press Enter. You will see that the 0 is entered and the cursor moves down to allow you to enter the next value in the first column. Continue entering all of the values in the first column in this manner. You can follow along with the next few screens which work through entering all of the values in column 1. Once you have entered all of the values in column 1, use the arrow keys to move up and then over to the first box in column 2. Then enter all of the data into column 2 as you did column 1. Now that all of the data is entered, we will use the linear regression capability of the calculator to find the equation of the line that models the data. To do this, press the Stat button again. Use the arrow keys to move to the Calc menu. The choice we will select from the Calc menu is option number 4, Linear Regression. You can use the arrow keys to move down to number 4 and press Enter. You could also press the 4 button. In this example, we will use the arrow keys. The linear regression function appears on the screen. To start the function, press Enter. The output information is now displayed on the screen. What the output tells us is that the line that best fits our data, as determined using linear regression, is the line y equals 3.73x plus 34. If you would like to, you can see the graph of this line by entering this equation into the equation editor and then pressing Graph. Because the problem does not ask us to find the graph, we will not perform this operation for our example. We should consider the application of this process, however. A typical application is to use the model for predictions. So let's consider the problem posed on the screen, which is to use your model to predict the number of pounds of waste that will be recovered in the year 2010. Using the equation we found by linear regression, we will now substitute 20 for x, because 2010 is 20 years after 1990, and solve for y. Y equals 3.73 times 20 plus 34. Therefore, y equals 108.6. We could estimate that there will be almost 109 million tons of waste in the year 2010. Remember, this is an estimate based on a linear regression. It will not be an equals, it will be an approximately equals. This is a typical example of a linear regression problem and an application of the resulting equation.